August 1945, 30,000 feet above Japan. Staff Sergeant Henry Irwin is the radio operator on a B-29 Superfortress when a phosphorus smoke bomb malfunctions and ignites inside the aircraft. White phosphorus burns at 5,000 degrees and cannot be extinguished with water. The bomb is filling the cockpit with blinding smoke and burning through the metal floor. Irwin picks up the bomb with his bare hands, crawls through the navigator's station while the phosphorus burns through his flesh, and throws it out the cockpit window. He collapses, his face burned beyond recognition. But here's what saved the rest of the crew: they weren't trapped in gun positions like B-17 gunners. The B-29's revolutionary remote turret system meant gunners could be positioned in the pressurized cabin, protected from the elements and able to help in emergencies. Irwin survived because crew members could immediately administer aid. This is the story of how one engineering innovation changed aerial combat and survival rates forever. Let me explain what made the B-29 so different from every bomber that came before it. The B-17, B-24, and every other Allied bomber had gunners physically positioned at their guns. Ball turret gunners hung in a sphere under the plane. Waist gunners stood at open windows in -60-degree temperatures. Tail gunners crawled into an isolated compartment at the back of the aircraft. Each position was cramped, cold, isolated, and dangerous. If you were wounded, help was difficult or impossible to reach you. Boeing engineers designing the B-29 recognized this was a fatal flaw. They needed a bomber that could fly higher and faster than anything before, over 30,000 feet at 350 miles per hour. At that altitude, the outside temperature reaches -70 degrees Fahrenheit. The air is so thin you need pure oxygen. Previous bomber designs couldn't protect gunners adequately at those altitudes. So Boeing did something revolutionary: they designed a fully pressurized cabin and moved the gunners inside it. But here's the problem that created. If the gunners are inside the pressurized cabin, how do they operate guns that are outside the aircraft in unpressurized turrets? The solution was the General Electric Central Fire Control System, the world's first remote-controlled defensive weapons system. Gunners would sit at electronic sighting stations inside the warm, pressurized cabin and control gun turrets mounted on the outside of the aircraft through electrical and hydraulic systems. They would aim using a computing gun sight that automatically calculated lead angles, and the guns would track their sighting movements perfectly. This sounds simple now, but in 1943 this was bleeding-edge technology. The system had to transmit the gunners' aiming movements instantly to turrets dozens of feet away with zero lag. The computing sight had to account for airspeed, altitude, target speed and direction, ballistics, and parallax, all automatically. The mechanical linkages had to be precise enough that the guns tracked exactly where the gunner aimed, even during violent maneuvers. And all of this had to work reliably at 30,000 feet in combat conditions. The survival advantages were immediate and dramatic. First, gunners were now in a pressurized, heated environment. They could wear normal flight suits instead of bulky heated suits. They could move around if needed. They had access to oxygen without being tethered to a specific position. The psychological benefit alone was enormous: you weren't isolated in a tiny compartment. You were part of the crew, able to communicate easily, able to help with other tasks. Second, medical care became possible. In a B-17, if the ball turret gunner was wounded, he was trapped in that sphere. Nobody could reach him. He would either survive until landing or bleed out, and the crew could do nothing. In a B-29, if a gunner was hit by flak fragments coming through the fuselage, other crew members could immediately provide first aid. They could stop bleeding, administer morphine, treat for shock. Multiple B-29 crew members survived wounds that would have been fatal in earlier bombers simply because help could reach them. Third, the efficiency increased dramatically. One gunner could control multiple turrets. The B-29 had 4 remote turrets, 2 on top, 2 on the belly, plus a manned tail position. But through a system of selectors, any gunner could take control of any turret. If fighters attacked from the right side, multiple gunners could direct all guns to that threat. The fire control computer would automatically prevent gunners from shooting their own aircraft if you aimed at a part of your own plane. The gun simply wouldn't fire, but like all new technology, the system had problems initially. Early B-29s suffered from electrical failures in the fire control system. Turrets would jam or stop responding. The computing sites were complex and prone to failure. Maintenance crews had to learn entirely new skills. They weren't just fixing mechanical linkages and hydraulics anymore, they were troubleshooting electrical circuits and computing mechanisms. The combat debut over Japan revealed another issue. Gunners trained on the system found that aiming through an electronic sight felt disconnected compared to physically pointing guns. The learning curve was steep. Some gunners struggled to judge distances and lead angles through the remote system. The Air Force had to develop new training programs specifically for remote turret operation. But crews adapted, and the system proved itself. There are documented cases where B-29 gunners successfully engaged Japanese fighters at ranges and angles that would have been impossible with manually aimed guns. The computing sight automatically corrected for the B-29 speed and the target's movement. Gunners just had to keep the sight on target, and the system did the rest. Hit rates increased compared to manual systems, the survival impact showed in the statistics. B-29 gunner casualty rates were significantly lower than B-17 gunner rates, even accounting for different operational conditions. Part of this was the higher altitude. Japanese fighters struggled to reach B-29s at 30,000 feet. But part was absolutely the remote turret system. Gunners weren't exposed to the slipstream. They weren't in isolated, vulnerable positions. They could take cover during heavy flak and still operate the guns remotely. One of the most significant survival factors was crew coordination. In earlier bombers, each gunner was essentially operating independently in their isolated position. In the B-29, gunners were sitting near each other in the pressurized cabin. They could communicate easily. They could coordinate fire. If one gunner's sight system failed, another gunner could take control of that turret. This redundancy saved aircraft and lives. The tail gunner position was still manned. Someone physically sat in the tail turret because rear defense was critical and the tail position had the best field of fire to the rear. But even the tail gunner benefited from pressurization and improved access. The tunnel connecting the tail position to the main cabin was pressurized. If the tail gunner was wounded, he could be pulled back to the main cabin for medical care. This wasn't possible in B-17s where the tail gunner was completely isolated. There's a documented case where a B-29 took heavy flak damage that wounded the tail gunner and jammed his turret. He couldn't move the guns manually. But he crawled back through the tunnel to the main cabin where he took over a remote fire control station and continued fighting, directing one of the belly turrets while another gunner handled the second belly turret. The aircraft survived the attack specifically because the remote system allowed this flexibility. The engineering team at General Electric continued improving the system throughout the war. Early problems were identified and fixed. Reliability increased with each production batch. Maintenance procedures were refined. By mid-1945, the system was working as designed, and gunners had complete confidence in it. The psychological impact cannot be overstated. B-29 gunners knew they had technological superiority. The Japanese fighters they faced were still manually aimed. The B-29's computing sights gave American gunners a significant advantage in accuracy. Combined with the .50 caliber gun's range and hitting power, B-29 gunners could engage targets at distances Japanese pilots weren't expecting. This changed the tactical equation. Japanese fighters had to approach more cautiously, which reduced their effectiveness. Post-war analysis showed that the remote turret concept validated. Every major bomber designed after World War II incorporated some version of remote or automated defensive systems. The B-52 used remote turrets. Modern combat aircraft use automated defensive systems descended directly from the B-29's technology. The principle of keeping crew members in protected positions while weapons operate remotely became standard across military aviation. but beyond the tactical and technological success, the B-29 remote turret system represented a fundamental shift in how engineers thought about crew survival. Previous designs accepted that gunners would be exposed and vulnerable. It was the nature of the mission. The B-29 design rejected that assumption. It said we can protect the crew and maintain defensive capability through smart engineering. That philosophy change saved thousands of lives. The crews who flew B-29s over Japan faced incredible dangers: flak, fighters, mechanical failures, fires, extreme weather. But they faced those dangers with a level of protection and capability that earlier bomber crews could only dream about. The remote turret system wasn't perfect, but it was revolutionary. It proved that engineering innovation focused specifically on crew survival could change combat outcomes. Staff Sergeant Irwin, the radio operator who threw out the phosphorus bomb, survived his horrific burn specifically because the B-29's design allowed immediate medical care from other crew members who weren't trapped in gun positions. He was awarded the Medal of Honor and lived until 2002. His survival, and the survival of thousands of other B-29 crew members, validates the engineering decisions Boeing and General Electric made when they designed a system that put crew protection first. The B-29 remote turret system remains one of the most significant advances in bomber defensive technology ever developed. It combined cutting-edge electronics, mechanical precision, and crew-centered design philosophy to create survival margins that didn't exist before. The legacy continues in every modern military aircraft that prioritizes crew protection through technology rather than just accepting casualties as inevitable. That's not just engineering progress, that's engineering that saves lives.